You're watching TelecomTV from Mobile World Congress 2019 in Barcelona. And joining me now is Arpit Joshipura of the Linux Foundation. Arpit, good to see you again.
Great to see you.
About a year ago or so, the Linux Foundation introduced this concept of CNFs, Cloud Native Network Functions. With the telecoms industry really just getting its head around VNFs, why the need to introduce CNFs?
CNFs, again, cloud native network functions, was a term we coined about less than a year ago. And the general concept was, how do you get the best of the telecom world with the best of the cloud world? And the advantages of containers are widely known. Everybody knows them. So how do you evolve the existing telecom networks today that have gone through several disruptions, right? From proprietary to open source to virtualization, through SDN and NFV, into VNFs, and now into cloud native. So how do you combine that value proposition of both and give it to the telcos so that they can get agility, efficiency, portability, and cost savings? That was the motivation.
So what stage are we at now? How is the Linux Foundation networking collaborating with CNCF on the next phase of CNFs?
So we took the projects with the most momentum in the Linux Foundation, Kubernetes, which is hosted by CNCF, and ONAP, that is hosted by LF Networking, and we collaborated together in the last year or so. As part of the collaboration, what we have been able to do is create a testbed, and this is an open source testbed, and we're calling it CNF Testbed. It's on GitHub. You can download it and put your test VNFs through it. But what it is essentially is it allows us to compare the power of containers with the power of VMs. And we can do it side by side across the same hardware and for the same VNFs or service functions, right, or apps, right? In an instance where they are packaged as a VM, we call it VNF. When we package it as a container, we call it CNF. So those are the application level. And in this testbed, as a demonstration, we've taken pieces of ONAP, specifically a couple of use cases around virtual CPE, virtual BNG, those things that essentially run as part of an ONAP use case. And we have packaged it both as VNFs and CNFs and run it on the exact same hardware. And the results are fascinating.
So the testbed is up and running and you already have some results?
Yes. The results that are running side by side today are showing anywhere from 6 to 9 times the performance of containers, right? And we're not even talking about portability here, right? Across clouds, right? So Kubernetes has kind of an underlying layer that kind of ONAP sits on, and the VNFs and CNFs kind of ride on, is really doing the multi-cloud connectivity. Along with that, this testbed is also part of the global CI/CD platforms that the cloud guys run thousands of jobs daily. They get a lot of integration points, and it's kind of a continuous integration, continuous development process. So you're getting the efficiencies, performance, and you're getting the constant update. So it's kind of very cool. And by the way, we are hoping that the rest of the telecoms put their own VNFs. You don't have to take our VNFs. Take your own workloads or take your own application. The test platform itself is open source. We're taking open source projects and testing them in open source. Open source is what the next 5 years are all about.
You mentioned orchestration. So how does this tie in with the work you're doing with ONAP, which is already very well supported by telecoms operators?
Yeah, so since we last talked, ONAP has seen tremendous progress, right? We're coming up with a 4th release in the summer, and it's called Dublin. And at the end of 2018, we had an amazing support from the global carriers. So if you summarize the total number of subscribers, mobile subscribers globally that are addressed by the participating carriers, we're over 70% now. So in just less than 2 years, ONAP has become the de facto automation platform. The community is extremely diverse. Originally it started off, by AT&T, China Mobile, a few of the carriers. Now it is pretty much the entire global diverse community, including the top 10 vendors, right? So all of a sudden the vendors have realized that this shared IP and shared innovation that gets created is something that individually they cannot do. And so they are all lining up behind it, and we're seeing tremendous momentum in the marketplace.
5G is obviously the big topic here at Mobile World Congress, but so too is the edge networking, edge computing. But what are the driving factors on the development of the edge? Is it automation, virtualization that's driving interest in the edge? Or is it the emergence of the edge that's leading to the development of orchestration, for instance?
That's a great question. So there are two things happening. The first is 5G is coming, and 5G means a lot of things to a lot of people. I won't go into the details of it, but let's assume for a moment it is many more things at a very low latency to a lot of people, right? In order to deploy 5G, and not just the radio part of it, there is one phenomena that needs to happen before that, and that's called network automation. You cannot have a device that's connected to a network on a call holding to get service. Okay, it's automation. Automation is mandatory. That's what ONAP gives you, and that's kind of phase one of prep that's going on. Okay, the second part of it is there is with 5G, and as we have seen, it's a lower latency, higher bandwidth, all the good things that come with 5G. The apps will require support closer to them. So we're talking about 5 to 20 milliseconds of latency where the edge is defined and the edge cloud is defined. So the biggest challenge there is even that portion of it needs to be automated. But today you have silos solving the edge problem. You have a cloud way of solving it, whether it's Microsoft, Amazon, Azure, Baidu, etc. You have a telecom way of solving problems with edge cloud, like project like Akrino, etc. You have an IoT and an enterprise way of solving problems, right, with IoT gateways under the building. What Linux Foundation did earlier this year is we launched a project called LF Edge. And it's a unified framework to bring these multiple projects across the cloud, across enterprise and telecom and IoT all together so that we can collaborate. And it has seen tremendous success. Just at launch, we had over 60 founding members. And that that's the largest founding member population that we have seen at launch. And the reason for that is everybody hates fragmentation. Nobody wants to pick a loser. They want to collaborate and go with a project or a set of projects that are winners. And that's what LF Edge and this is providing. And then it's kind of linked with the automation at the core. So you got core automation, edge harmonization, and then 5G in the radio, and then a whole ecosystem of mobile phones, new applications and edge applications. They're all coming up. I think I can see the pieces coming together.
In parallel with all the work that's going on within the open source community, there's the traditional standards development organization work that's really driven the development of telecoms over the past decades. There's been a lot of call for closer collaboration and integration between these two areas. What's the stage we're at now? Are these two approaches harmonizing sufficiently yet?
So from an SDO and an open source perspective, I have some very good news, okay? Not only have we started talking, we've actually gone in and actually implemented standards and code that is supposed to be kind of working together. So let me tell you what happened. 3 years ago, it was open source versus open standards, okay? We came in and we came out with a white paper on how to harmonize that. And to the credit of SDOs, everybody stepped up. They worked with us collaboratively. And over the last couple of years, we have seen a drastic change in both camps, okay? We have had formal collaboration, legal and marketing and code with MEF, TM Forum. We have had ETSI specs both at the ISG level of NFE, ZSM as well as MEC. We've had 3GPP work that is kind of being done. and a whole variety of other standards that are very actively being coded in the open source community. Now, the way it works is very simple. The mandate we gave to both parties is, if a standard exists, code it. If it does not exist, code it and then push it upstream to the standards. And we are here to support you on that. If you put it in that terms, it's very simple, right? Now, devil's in the details, but I'm really excited that the standards groups have stepped up, the open source groups have stepped up, and the collaboration is in full swing. And you will see even more of this as kind of the RAN and the software-defined radios and the ORAN portions come in. And we're hosting the software portion for that at the Linux Foundation. So we will be looking at even a broader areas of standards and open source collaboration. So I think that's probably the last time you should ask this question. Next year it will be a non-news item. But I'm excited about the possibilities.
That's great news. Arpit, thank you very much indeed.
Okay.
Appreciate it.
Thank you.